Our second presentation is from Ken Whelan. Ken Whelan will be well known to many of you, both for his science and his avid interest in angling. He was formerly a director of the Marine Institute in Ireland. He's an ex-president of NASCO, and he is now the research director for the Atlantic Salmon Trust. And Ken is going to provide us with an introduction to how salmon populations work.
Thank you very much indeed, Ted. Good morning, ladies and gentlemen. My job this morning really, I think, is not to teach you anything new, but it's really just to lay the foundations in terms of reminding us in the context of wild populations exactly what the situation is. First of all, just to lay emphasis on the fact that salmon populations, this might seem very trite, but it's very important, I think, to remember. They are complex, they are highly variable, and they're highly structured. And in the context of any intervention, such as the ones David was describing, we need to keep that in mind. There's also specific adaptations for life histories. So in certain rivers, in certain systems, there are very specific adaptations, and Eric will be talking more about that. And we talk about discrete, self-sustaining populations, but I think we really have to believe in that. That's certainly my view, that they are discrete. And if they are discrete, we have to understand how they're working so that we can help them if help is needed in the context of stocking. I think as our models become more and more complex, we have to keep reminding ourselves what goes into those models. The numbers that go into those models are the very numbers that generate our conclusions. So our models basically are as good as last year's numbers. So collecting those numbers, understanding those numbers, and integrating those numbers is so very important. And certainly in terms of numbers themselves, without numbers, I don't think you can manage. The salmon itself has been around a long, long time. And what we have learned in very recent years, certainly when I was in school, there was always little bits of Ireland and of mainland Britain that were shown as free of ice. We now know that 24 to 27,000 years ago, everything was covered in ice. So the fish that we have today are fish that came in that period, probably from 14,000 years ago to the present. But these fish have been around a lot longer. The original ancestor of the salmon was probably about 50 million years ago. And the other thing is that they're very, very good at adapting. They do this stuff for a living, and they've been doing it an awful long time. And certainly in terms of the refugia that I was talking about, where the salmon obviously came from if everything was covered in ice, the refugia were actually generating and putting in place then various invasions, not just a single invasion, but invasions that came at us over time. And those changes, those differences rather, are very much reflected in today's population. That's part of what we've inherited in terms of the salmon populations that we're attempting to manage. And nature has done a quite extraordinary job in terms of the migratory fish species. And whether you look at Atlantic salmon or Pacific salmon, just think about the range of possibilities that are there. If a salmon has a bad year, is it as catastrophic as we really think? If you go right across the range of salmon, you can have salmon smolts that are a year old, but equally you can have salmon smolts that are 7 years old in very remote areas of Russia and so on, where basically you're looking at one invertebrate per square mile, and these creatures are mainly feeding off terrestrial organisms. Equally, the sea ages, you can look at one sea winter, look at 7 sea winters. You can look at fish that are coming back in spring, fish that are coming back in autumn, fish that are coming back in the summer, and a range of different types in relation to the actual size and indeed the life history of these fish. Just a small example of 2 rivers that I know well in Ireland, the River Drowse and the Owenmore River. River Drowse in Donegal and the Owenmore in the northwest in County Mayo. In the case of the River Drowse, we actually have the salmon season opening on the 1st of January. So you have fish going in from November on. And these are very large multi-sea winter fish. In several cases, each year, fish come up out of the sea, travel about a mile upstream, and sit in a pool at a bridge until the following December before they lay eggs. So those fish are actually sitting in fresh water while their companions are actually spawning. Again, a very good safety valve. In the case of the Owenmore, Phil, that was mentioned earlier in the context of our extinction vortex, and hands up, I have to admit part responsibility for that. But in terms of the Owen Moor itself, we were really surprised when we started to look at beautiful 12 and 14 pound fish coming in the late autumn to discover that these were grilse. We actually had to con a new approach in terms of putting notes on the scale envelopes. Rather than saying 2.1 plus, we had to put down 2.1 plus plus. So these fish were so close to being springers, it was ridiculous, and yet they decided that they were going to come back and spawn. So there's a huge variation in terms of these life histories. If we go through slowly then and just look at the various stages in relation to the actual life of the fish themselves, and just think a little bit about the various components. And in several of these slides, I'm going to keep coming back to numbers because I think numbers are really important, that we begin to get a feel as to what's happening in the context of the rivers. Certainly, I'll come back to this in a little while now in relation to the eggs and the egg numbers. That is a really, really important point. The point as to whether or not you think 100,000 is a big number. I think we need to come back to that a couple of times over the next couple of days. The eggs obviously go into the olivins and the fry and the par, but really in terms of the pinch points, the pinch point really is what actually is involved in making a smolt. And you're doing really well if you get 1.5% survival from egg to smolt. You're doing really badly if you have 0.25%, but on average you can take it at about 1%. So there's about 1% that actually comes down that river and goes to sea as a smolt. So that's your starting point in terms then of moving out to sea. And in relation to the survival then of the post-smolts and the survival of the fish at sea, you're dealing already with a very depleted number. And what we know now is that maybe 40 years ago, we had somewhere between 7.5 and 8 million Atlantic salmon at sea. That was the total population at sea. We're down to about 3 million now. Why is that? Well, in reality, we have different reasons. There's obviously a component, and one component is the high seas commercial fisheries, such as Greenland, and the earlier high seas fisheries. What's the real hit there? What exactly is happening in relation to that? Again, numbers are required. We need to quantify that. At the moment, we just accept numbers that come to us via the authorities in Greenland. We really need to scientifically know exactly what the hit is in terms of those high sea fisheries. In relation then to the return journey, again, 40 years ago, it wouldn't have surprised us to get 30 smolts back out of every 100. We're doing really well if even in grill stocks we're getting 10 to 12 back. In some areas we're seeing as low as 5 out of every 100 coming back in terms of the grills, and far lower numbers in terms of the multi-sea winters. So in relation to pinch points, that's a really important area and one that we have to be very conscious of. We had a great paper a few weeks ago by Guy Maul in relation to the Usk and the Usk estuary. And this year in particular, I've been very struck by the number of reports I've had about fish that were having difficulty in the lower end of rivers with the very high water temperatures we were encountering. And certainly some of the work that David Solomon has done previously indicated we can lose up to 50% of our fish in those estuaries. If we're facing into climate change, or we're facing into a situation where we're assigning mortality to marine mortality, we always have, and I'm very guilty of this, we always think about these high seas areas. But in reality, we need to be conscious about what might be happening at the very mouth of the river itself. If you have a surplus of fish, then you have your commercial fisheries and you have your rod fisheries. You have your in-river mortality, and again, we need to be conscious of the fact that there are natural mortality factors involved in terms of the migration upstream, and then, of course, you have the spawning mortality. So I think that is beginning, anyway, to lay a tapestry for us in relation to the areas that we need to be looking at. So what's driving the productivity of these rivers? Certainly the underlying geology and the overall water chemistry is so important, and also the aquatic vegetation and the amount of that vegetation. The quality and indeed the quantity of water, as we saw from the recent flows workshop that we had. And a reduction in the quality or the quantity can have all sorts of implications and all sorts of impacts. The key area in many ways, again, we're back to temperature and we're back to these flow rates. And certainly these fluctuating temperatures and the temperature regimes that we're seeing in the ocean and seeing in fresh water, we need to know more about them. These fish are cold-blooded. They're going to react very strongly to certainly any maintained change in terms of temperature. And the actual state of the rivers themselves, in terms of rivers that have already been dredged or been affected physically in some way, and the land use policies that have been in place in the various catchments that we've been looking at. So what are the concerns that we often hear? And some of these questions very much parallel the questions that David raised earlier. Very often you'll hear said that natural reproduction of salmon is very inefficient. That it's, I don't know where this number comes from, but very often you'll hear, well, it's 20%. And hatcheries really, you can get 100% or very close to 100% in terms of hatching out from the eggs. So it's obvious you need a hatchery. Very often we'll hear the quote, well, nature just needs a helping hand. We'll fill the gaps. And if the catches fall, as David said, maybe we do need to start looking and seeing what we can do to try and support those catches. And the obvious way to do it is to do it with the hatcheries. But in reality, the natural fertilisation rates are actually very high. And some work that my team and Alan Youngston's team did some years ago, we were able to show that in some reds, up to 7 individuals contribute. And the really key animal in all of this are the precocious male pair. And the precocious male pair really come into their own when adult numbers are very low. And it's something that, again, we need to take into account. I think it's very important, as I mentioned, in relation to the eggs, that we get our head around this idea of the number of eggs. And just a rule of thumb, if you have 8-pound females, which may be a little bit big if you're dealing with a grilse fishery, but in general, if you have 8-pound females and you have 200 of these, that's 1 million eggs. So it's useful just to be able to think about that and think about a situation where you have maybe 10,000 fish and you have 50 million eggs. So really, your contribution, what is it going to do to try and support things? And how, as David said, are you going to make sure that you can define a set of objectives that can actually add to that potential production? The other thing that's very important to understand is that, and we'll come to this at the very end of the talk in relation to a couple of curves that I'll finish with, but certainly biologically a stock could be sustainable even with relatively low numbers of salmon. And that's a really important concept, and it's one that we can discuss a little later. An example again might help. It was probably the roughest day of my life, this, and it was all due to Martin O'Grady. Martin got the flu, and he had done this fantastic survey of the River Suir about 20 years ago in Ireland. And the River Suir flows out as one of 3 rivers into a common estuary. And at the mouth of that estuary, there was a small fishing community. And these were really tough guys. And it was said during the time when the drift nets were at their peak, these guys took 2 days off. They took Christmas Day and they took Easter Sunday, and that was it. So the numbers of fish coming into these rivers were really low. I mean, from an angler's point of view, the angling had almost finished. There were no in-river fisheries at all. There was a huge pressure on to put a hatchery in place. So Martin went down and did a really thorough examination of the river. And we were absolutely amazed at the number of par that was in the River Suir at that time. And I was, of course, dispatched down to Waterford when Martin was sick, and I was savaged by the collected group of angling clubs who just could not accept the fact that the juvenile fish were in the river. But it makes the point that if you're in a situation where you have an absolutely pristine river, where you have a reasonable escapement of fish that may be well below your so-called conservation limit, the river will actually compensate. You're playing a very dangerous game genetically, but at the same time you have to be conscious about what's in the river before you go investing into your hatchery. And certainly if a female salmon was only laying 5 or 10 eggs, there would be a very good case for trying to get more females into those rivers. But when you're in a situation where female salmon, as I say, are laying hundreds and hundreds of thousands of eggs, well, then you're in a very, very different situation. And the relationship between the number of spawning adults, the number of eggs that are laid, and the resultant juveniles is, again, a very complex one. And certainly, in many ways, it's an indirect one, and it's not a simple matter of just equating one bit of the formula with another. I always think it's very good to look at this in the context of a pyramid. And if you handed that pyramid to a really keen angler, he would immediately look at the top part. He would immediately look at the green part. If you handed that pyramid to a manager, he'll immediately look at the bottom part. And he'll look at the amount of eggs. And certainly, when you think that probably 90% of all the salmon alive today are less than 12 centimetres. It's the bottom part of that graph that in many ways is the important part, because that defines the carrying capacity, exactly how many juveniles a particular system can take. And as I said earlier, is 100,000 a big number? Probably not in salmon terms. It's probably the progeny of 20 to 25 females, and yet you put a huge amount of effort in the context of hatcheries to produce 100,000 eggs. In terms of the marine environment, and I won't labour this, but just to remind us that in terms of the marine environment, we have a lot of factors that are changing. Water temperature, salinity, the surface currents. We certainly learned from Salsea the importance of these surface currents, which are driven by wind. We had imagined that the big, powerful currents off the west coast, they were the main components, if you like, in terms of driving the mortality or the survival of these fish, whichever way you looked at. We were really surprised at how important the surface layers of the ocean were and how variable they were in terms of the fish's ability to find their home, if you like, in their feeding grounds. The food availability and the composition of that food, predation and bycatch are all factors in the marine environment. And all of those working together are pulling down those numbers at the moment. In terms of the marine survival then of the smolts, as I mentioned, certainly in the 60s we were looking at much, much higher marine survival than we were now. And some work that's just being completed at the moment based on some of the Salsea results has a lovely comparison where we look quantitatively at some of the smolts that are going through the Bay of Biscay, and we compare that with the northwest of Ireland. And if you think about that shelf edge current for a moment and how close it is to County Mayo and the northwest of Ireland, and the kind of survival rates that we were recording from the Burrishoole index system, which people were very dubious of at times and saying they're far too high, the fish actually had quite a short distance to go in order to find the main highway north. Whereas in the context of the Bay of Biscay, it's much more complex. And in Edinburgh last night, John Armstrong showed us some graphs of the North Sea, and the North Sea is equally complex. And that may be a factor that we need to take into account, and we need to try and understand more. And even at times when the actual survival of the fish is poor, we're in a situation where there are exceptions. We saw this year a huge improvement in terms of the number of juvenile eels coming back. Nature always confounds you. And certainly in the context of the work we did on Salsea, we saw some years where there was actually relatively good survival, and years like 2008 when the survival was actually very low in itself. I promise you there's only one graph, but I did think it was important for us just to start thinking about this particular graph, which is the one that we often see when people are talking about populations. And at its simplest, it's just the number of adults and how many smolts in thousands those adults are actually generating. And again, you can see in this particular graph that you are talking about significant numbers of fish. You're talking about 5,000 fish, you're talking about 6,000, you're talking about 11,000. So what you have in the early part of the curve is a direct relationship. The more adults you have, the more smolts you have. But obviously the factory is filling, and you're filling the assembly line, you're filling it. When you get to this point here then, if you put too many animals into a confined space, you may very well see a situation where this particular line starts to drop. Now, that point of the curve is always subject to a lot of debate. Does it flatten off? Does it dip or whatever? But the truth of the matter is that you reach a point where the factory is full. And it's interesting to see the difference between what would be struck as the conservation limit, the limit below which it's not advisable to go, and the maximum ability of that fishery to produce animals. So you're going from 5,000 to 11,500. That's a huge difference. And as I said earlier, even below that 5,000, it doesn't necessarily mean that you have to have an intervention. It may very well be that the population, because of its ability and its inbuilt safeguards, it may be in a position where it can actually bounce back. The conservation limits themselves, generally the management regime in all of your rivers is not actually managed on the basis of conservation limits. There's an additional component. There's the management target. And normally it's 40% or so more than the conservation limit. So there's a bit of a slack, if you like, a little bit of slack that's actually in there. Most fisheries at this stage are run on a decision structure basis. So all of the data that are collected over the past year are looked at in the context of those decision structures. And they're looked at in the context then of both the conservation limit and in terms of the management target. And one other point that was on the graph I just thought I'd mention in case you were wondering about it, the replacement point. That's basically the number of adults that was needed to produce that number of smolts is replicated. Those smolts then produce exactly the same number. So it's an as-you-were situation. So hopefully you'll now begin to understand that with the best will in the world, and no matter how sophisticated our models are, this is a very complex area in terms of actually predicting the consequences of any management action. And if that management action is an effort to try and plug gaps and to try and assist and support wild stocks, then it really does need those very clear outlines and guidelines that David mentioned earlier. We really do need to know where we're going with this and how we manage this. AST and IFM at the moment, with the help of Ted and some other scientists from the Marine Institute and so on, and from EA, we're attempting at this stage to actually put together let me call it a web tool, really, or a demonstration site, so that you can start looking at some of these numbers and start plugging in these numbers yourselves and actually seeing the consequence of a management action. So if you decide you want to build a scenario where your fry are halved, or you want to build a scenario where your smolt survival is halved, or a scenario where you double your rod catch, what would the consequences be in terms of what in essence is that salmon cycle and that salmon wheel? And hopefully it will give you encouragement to look at this. This is not rocket science. This is accessible to everybody. These are numbers that anybody can get their head around with just a little bit of time and a little bit of effort. But it does make a big difference in terms of understanding then the criteria against which you're going to try and lay out your stocking programme and indeed lay out the protocols that go with that particular programme. Thank you.
Thank you, Ken. We have time for a few questions. If you wish to ask a question, could I just ask you to stand up when you say it so other people can hear, and just say your name so people know who you are. Any questions? Yes.
Ken, just want to draw out some of your knowledge about fish at sea. I do understand that in the freshwater environment, survival is sort of density dependent. It's been described in the past that survival at sea is being density independent. And in terms of my question really is understanding when the food sources at sea decline, survival decline, do you see any evidence really of actually that becoming density dependent out at sea? Because I'm really what I'm trying to get at is it not just about numbers, it's also about quality, about the fish that we tend to see?
No, I think that's a very good question and a very important question. In the context of the first phase of the SALSI programme, really we were drawing a map. We were looking at migration and distribution. We really need to get to the stage now where we actually try and look at those areas and look at them at each stage of the migratory process. The early post-smolts, the fish at sea, the feeding fish, the fish on their way back. And through NASCO, Ted is chairing a group now to look at this idea of partitioning the oceans, so we can begin to understand the mortality that's occurring as a result of feeding issues at one stage, but then also some of the climate change issues on the return. So it'll really be, I think, at that stage that we can comment on that. What we did so far, I think, was fairly crude in many terms in relation to the actual feeding. We collected the fish, we looked what they were feeding on, and we did locate some areas where the densities of that food was very low. But other than that, we haven't really been able to pull it together to such an extent that I could fully answer your question at this time. But that's really what we're zoned in on now, is to try and answer those questions and to understand what is killing the fish and where they are actually dying at sea. We do know that it's linked in terms of the post-smolts very strongly with changes in the plankton and with climate change. But how true is it then in the other areas of the fish's life at sea?
I think just throwing in a comment on that, that there is very little evidence of density dependence at sea, but I believe going back nearly 30 years, Mike Chadwick suggested that in Canada they had evidence of density-dependent mortality of post-smolts. The problem is, generally, once you get more smolts, you often get smaller smolts, and those smolts, therefore, may be suffering more mortality simply because they're smaller. So, as Ken has said, that the life cycle is so complex, it's very difficult to tease apart some of these separate effects. I think there was a question over here, or a comment, yeah.
My name is Sean Doherty. I'm from one of the villages you mentioned down the shore in County Waterford. And my question is, you stated the importance of figures, and I was born in 1964. And previous to 1963, around 1963 in Waterford Estuary, salmon were quite scarce. In 1963 they came, very, very heavy runs. There was no sea fishing, and they came up until some years ago. The older fishermen, going back a generation or two before that, had witnessed similar events where vast numbers of people from our community, which we would call ourselves indigenous Irish fishermen, not modern fishermen at sea that we talked about. This thing has happened over the years, and people have had to go away. And what we feel like is that not enough emphasis has been put on this traditional knowledge. Like we have got, a lot of from contacts we've made with First Nations people in Canada, they have come back to us and said, well, in Canada, when they took out the fisheries, it didn't have a big effect on the stocks. It was the fish farms, the modern development, and that's where we're here with an interest from traditional fishing villages like that. And sometimes I think the angling community forget that there's another side to traditional fisheries in these islands, and we see ourselves as indigenous people. We go back many, many, many generations. And on your figures there, that's what strikes me. That the historical oral tradition from anglers as well as commercial men should be taken into consideration, because, just a finish on this, a lot of emphasis has been taken on this. In our river, about 20 years ago, it was grinds put in, massive grinds, river training work, going right into the best salmon river in Ireland. And nobody ever done an impact study on smolts. Now, in the springtime, when the smolts are running, all along these grinds, cormorants are there, picking off the smolts. Now, it's illegal to cull cormorants, but my information is the other one that has been shot, for information that has contained a large number of smolts. So thank you for.
Okay, thank you. I think there's about 10 really important points there, which hopefully we'll manage to come back to. We'll manage to come back to during the rest of the discussion, and they're the sort of points we'll welcome when we have the broader discussion. But I'll just wait and make one point on that, if I may. Certainly, Paddy Boylan, who spoke earlier, and David Summers, when they were doing their PhD was looking at all of these cyclical changes and looking at all of those traditional fisheries and how they actually blended in and what their experiences had been. And I think that's a really important point. I don't think we can afford to miss out on any information that we may have available to us. I think it is all part of a very important mix.